This is the Hoover Dam built by the United States in 1931, before that it was a valley. Engineers want to build a dam here. The normal idea would be to design an upright concrete wall in the middle of the canyon, but if this is the case, as the amount of water storage continues to increase, the pressure on the wall will slowly increase, and eventually lead to the wall bending or even cracking. For this reason, engineers at the time came up with a way to make the dam curved, so that the properties of concrete could be used to resist the pressure of the water. But there was another problem. When the water was high enough, the center of gravity of the concrete wall would be higher, and it was likely that the wall would collapse. So the engineers made the dam a curved dam with a wide bottom and a narrow top, which solved the stability problem perfectly. The first step in building the dam was to blast away the weathered rock on the surface, and then workers cleaned up the weathered rock on the surface to reveal the really hard rock layers inside. Deep trenches are then dug around the perimeter, and then workers stack wooden planks to model the entire dam, followed by injecting concrete into it. If the concrete was routinely injected directly into it, the heat of the concrete would cause problems with expansion and cracking. Instead, the engineers proposed stacking small pieces of concrete, placing a steel pipe in the center, and injecting a coolant into it, so that the reinforced concrete dam would not crack or expand due to high temperatures. Next came the construction of a hydroelectric system for the lake dam. Behind the dam is a powerhouse the size of 2 soccer fields, containing a total of 17 turbine generators with angled transmission towers attached to them. Why are these towers placed diagonally instead of upright? Because of the slope of the canyon, placing the transmission towers upright would cause the high voltage wires to touch the surface of the mountain. To generate electricity through turbines, there must be a large enough flow of water. So engineers used explosives to blast through the rock above the flow of water at the dam, and workers used cranes and conveyor belts to clear out the debris inside and dig a tunnel like this. After removing all the debris, a concrete pipe is placed inside. But because of the water flow, the concrete pipe may be damaged by the water over time, so the engineers used steel plates to make the lining of the pipe, and laid a layer of steel structure in the middle of the concrete pipe. And each hole in the center was connected to a turbine generator, and at the time, because both the turbine and the generator were so heavy, they built a rope crane above them to complete the installation of the turbine and the generator. This large crane is actually made up of several pulleys, a specialized bracket below and 4 pulleys above. While the 2 motors are connected to the large pulley on the right, they are connected by ropes, and additional pulleys were used to create a landing mechanism. Back to the turbine generator part. Once the water flows through the tunnel into the turbine, it will drive the blades inside the turbine to rotate. The blades are uniquely designed to control the speed of rotation according to the size of the water flow, and the pressure difference of the water flow is the key to rotate the turbine. Above the turbine is an adjustment mechanism that controls the angle of the turbine blades to control the amount of power generated. Above the turbine is an oversized rotor, which is the key to generating electricity. There are coils and coils of copper wire wrapped around it. No permanent magnets are used here, so the electrons need electricity to generate a magnetic field, and a controller above controls everything. This is all that's needed to convert the pressure of the water through the turbine generator into electricity at Hoover Dam by controlling the flow of water.